So here's our study guide. We're 8.5 to 8.8 study guide. You can use it as a cheat sheet for your quiz tomorrow. We'll first start out with 8.5 quadratic formula. Here I have x equals negative b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. You're more than welcome to still graph that equation if you want to. That's completely up to you. But when you come up to irrational numbers, this is what we're going to do. First of all, we're going to round to nearest hundredth. So I'm going to write on a keynote as nearest hundredth as our answer. All right, so just a reminder, here's A, here's B, here's C. All right, those are going to be A, B, and C. So when I am going to do is substitute the B and put negative 12 in its place. Substitute the A, put negative 1 in its place. Substitute the C, put negative 18 in its place. So our equation will look like x equals, since in our equation negative b is already negative, a negative times a negative makes a positive, so that'll turn to positive 12 plus square root of b squared, which is negative 12, minus 4 times a, which is negative 1, times c, which was negative 18. And all that's going to be divided by 2 times negative 1. All right, so I'm going to plug this whole equation into Desmos. The only thing I'm going to change from each equation is this part right there, okay? One equation I'm going to have a plus, one equation I'm going to have a minus, so I'm going to go ahead and plug that equation onto Desmos. But everything up top, I'm going to put that inside a huge set of parentheses, so that way Desmos can split it up. All right, so one of my x's going to be x equals negative 10.24. Remember, we round to hundredths place value, so one of my x's and then I'm just going to retype that same equation, except I'm going to just change that plus into minus. And then everything's the same. You want to just change that plus to minus on the very top. That's next to that 12. And be negative 1.76. And then that's how you do your quadratic formula. If there's a number where the 0 is at the very end, just move it over to, or if there's a term there, just move it over to where everything is, so that way it'd be written in standard form. In 8.6, we talk about the square root method, okay? This is when we have two terms. We need to get everything isolated. We're solving for basically the x or the variable. In this case, we have 6x squared equals 54. We already have them split up apart. The only thing I need to do is try to get this x right here by itself. You just need to get that x by itself. That's all we have to do. So we're going to do a 1-2 step equation to solve for that. Well, first I got a 6 times x squared. I need to divide that by 6 from both sides of the equal sign. If my pen would cooperate, maybe if I zoom in, that might be helpful. Let's see, that will work. There we go. So I'm divide 6 from both sides of the equal sign. Then I have x squared equals 9. So then next step I'm going to do is take the square roots, because we can do inverse operations. So inverse operation of an x squared is or a exponent 2 is a square root symbol. So I'm going to take that inverse operation, square root. Now I have two x's. One x can be -3 and +3. In 8.8, we talked about that yesterday, where we are given the equation. We just need to figure out what part is what. So here we have a scenario when Joey dies off a diving board. The equation for his pathway can be modeled by h equals -16t squared plus 15t plus 12. We need to find his maximum height, and also to find the time it will take for Joey to reach the water. As I mentioned in the notes yesterday, that we can do two ways. We can go ahead and solve for the h, solve for the t, all that kind of stuff. I think that's complicated. Let's just use Desmos to help us out here. So how we can use Desmos to help us out? We can change this equation to y equals. Let me change that to a black pen. My equals -16x squared plus 15x plus 12. I can plug that equation into Desmos, that exact equation. So my x values in this equation is going to be will be representing the time, and the y values will be representing the height. We are looking for Joey's maximum height here in this equation. So how we can find Joey's maximum height? We look at the vertex of the graph that we just graphed on the right side. The vertex to turning point. So I'm gonna click where it makes this turn. I'm look at the y value. That's all I care about. So the y value is going to be 15.51563, round to the nearest hundred. So it'll be 15.512. Or 52, I'm sorry, not 512. And we're using, didn't say what metric, so we'll just keep it 15.52. That was maximum height in this graph. Part B asks us the time it will take for Joey to reach the water. Remember, we're going to have two x-intercepts. One's going to be on the left side and one's going to be on the right side. I just care about the right side. I don't care about the left side. You can't have a negative time frame. Time can only go forward. Time is always going to be positive. So I'm going to use the right order pair. So let me get rid of that left order pair. And is the x value 1.4535. I just want to round to nearest 100. So it'll be 1. Better. Decimal place, 4.5 seconds. And then the last question. Eva is jumping on a trampoline. Her height h at a time can be modeled by equation h equals -16t squared plus 20t plus 6. This one's a little different, but it's asked, would Eva reach the height of 14 feet? We're just going to see the max height. So I'm going to just go ahead and change this equation to y equals -16 x to the second power plus 20x plus 6. Plug that equation onto Desmos for us, see what the max height is. If it does reach that 14 feet, then we can say Eva was able to reach that. I'm going to click on the vertex. My max height was 12.25, so my answer would be no. 12.25, and I'll conclude chapter 8.8 for your quiz tomorrow.